All right, guys, let's go. Number 7, constant rate of change. What is the rate of change? It describes how one quantity changes in relation to another. Constant rate of change is when the same rate of change between two quantities is the same. Kind of a tongue twister. So if this guy is going 60 miles an hour and this guy is going 60 miles an hour, and they're going 60 miles an hour for 2 hours, they're constantly going 60 miles an hour. Woo. The table shows the amount of money the Booster Club makes washing cars for a fundraiser. Use the information to find the constant rate of change in dollars per car. So since it's asking me to find my dollars per car, I essentially want my unit rate of this. How many dollars per each car? Well, I see that I increase 5. Every 5 cars, my dollars increases 40. Right? First guy tells me this. If I add 5 more, if I add 40 more. So I have $40 for 5 cars. And I can divide those. 40 divided by 5 gives me 8. 5 divided by 5 is 1. So my constant rate of change would be the number of dollars earned increases by $8 for every washed car. Not too bad. Remember, miles per hour consistently going up. The table is shown. Hey, the miles a plane travels while in flight. Use the information to find the approximate constant rate of change in miles per minute. So instead of miles per hour like the car, we're doing miles per minute. So I need to get my miles, or we'll do my first one. 290 over 30. So I want to divide both by 30, which gives me 9.67. It's 66666 repeating, which I'll round to 9.67. And again, if I do that division here, it'll give me the same number, and here, and here. If you don't believe me, check your calculator. The number of miles increases at a rate of 9.67 miles per each minute that passes. Yeah. All right, table shows the number of students that buses can transport. Use the table to find the constant rate of change in the students per school bus. Pause video, give me an answer, see what you get. Maybe. I don't know why that's doing that, but okay. Students per bus increases of 72. I have no idea why it is outlining the T. Don't ask me. The number of students per bus increases at a rate of 72 students per bus. Next one. The graph represents the distance traveled while driving on a highway. Find the constant rate of change. So when I'm doing this, I'm always talking about miles per hour. So I always want to talk about the distance or the miles over the hours. And I know this graph is kind of difficult to read, but if you notice, the time is broken down to 0.5 or half an hour, then an hour, then an hour and a half, 2 hours, 2.5 hours, so on and so forth. So when I do this, and I'm going to have part type this because, handwriting. Maybe not. It doesn't look like my computer's wanting to respond too well right now. Did I just lag in IRL? Oh, sad day. Yeah, there we go. Okay, so no typing is happening. There we go. I want to go miles. Nope. Over hours. And since I'm constantly changing, I want to do the, oof, I didn't give myself a lot of room on this. I want to do the change of miles over the change of hours. And when I'm talking about something changing, or I'm trying to talk about how things have changed, how much time has passed, how much has gone on, when I'm dealing with a change, I typically take the later guy minus the earlier guy, or the bigger guy minus the smaller guy. If I originally had this amount and I added more, I'd see how many I increased. I would subtract those guys. And I'm going to pick 2 points to discuss that. And I think I'm going to pick these two to use as my informational key points. So the change in miles. So I stopped at 120. I started at 60. So I'm going to take 120 minus 60. Or the change in hours. It's still using those same guys. And I ended at 2 hours and I started at 1 hour. 120 divided minus 60 is 60. 2 minus 1 is 1. So this guy or this vehicle or you traveled 60 miles per minute, hour per hour. That'd be cool if you did 60 miles in a minute. Dude, you'd be like speed lightning. And it's a constant rate because it's consistently increasing. If you notice, say I had chosen to pick the first 2 points, I changed to red. Please respond. If I had chosen to pick the first 2 points, 0 to 1 increases 1, so I increased 1 hour. 0 to 60 increases 60 miles, so 60 miles in 1 hour. I could have also decided to use the last one and the first one, or I could have even still done the last one and this one. It doesn't matter. I could have picked any 2 key points, as long as I talk about the change in the miles divided by the change in the hours. And I ended up not liking this question, so I threw it out. By that same logic, I really want you to try this one. If you are struggling and you have no idea, call me over conveniently, quietly when I'm not teaching at the board, working one-on-one. Raise your hand. I'll be there in a moment. I recognize you. I may not instantly identify you, though. I'll be like, oh, I'm going to be right there. Okay? So give me some time. So again, pause the video, try it, see what you get. All right, this car is going at a distance of 30 miles per minute. Oh, I wrote it in my thing too. It's miles per hour. We never go miles per minute. Too many conversion stuff. All right, last one. The table and graph below, technically above, show the hourly charge to rent a bicycle at 2 different stores. What store charges more per bike? Explain. So pedal renters increases every hour and cost increases every $12. I went down too low. Super Cycles, again, it's kind of hard to read. We're going to work on reading this one together. If I follow my line, is actually a 1. If I follow my other dot, it's actually a 2. I know it's very squished, but it's similar to the one prior where it went a half hour, an hour and a half, 2 hours. So I know it looks like 1,001 numbers squished together, but it's saying 1 hour and 2 hours. So every hour increased, it looks like it goes a different amount. So we're going to determine those rates to see which is the more expensive one. Let's discuss pedals, and I gotta make sure my face is not like that. So I want to talk about price per hour. So I want to discuss these this guy, because I can physically see the difference. So 24 over 2, which I can divide both by 2 to simplify, gives me $12 per 1 hour. We can kind of see that increase here. That is visually shown to me. That's pretty easy to read. However, the second one, not so easy to read. I'm going to switch to red. So again, I'm doing cost per hour, so I have to do the change of my cost. So I originally end at 16, but I originally started at 8. So 16 minus 8 over the hours. I ended at 2. I started at 1, so 2 minus 1. 16 minus 8 is 8. 2 minus 1 is 1, so I get $8 per hour. But what was the original question? Which store charges more per bike? Well, if this one, Pedals Rentals, they always have to be cute. Pedal Rentals cost me $12 per an hour, whereas Supercycle cost me $8 per hour. In my opinion, $12 per hour costs more. It is more expensive. So Pedals Rentals charges more per bike. And we're done. Woohoo! Go football.